Hi everyone, welcome back. We continue on the topic 3 under the subtopic of sampling. Now we continue with the dissolution of sample. So how do we dissolute the sample? For the solution, we can using solution for dissolution of sample or we can using solid technique for the dissolution of solid sample. So most of the analysis, the sample in the lab, it can be done using solution. So we have to choose the right solvent to dissolve the entire sample rapidly, or we can do the analysis using solid. So if you want to analyze the solid form of sample, we have to employ the etching technique. Etching is the heating of substance to leave only non-combustible ash, which is analyzed for its elemental composition. So for the etching technique, we can have wet etching, dry etching, and also microwave infusion. So wet etching, uh, to treat the solid sample by using acid digestion to producing a clear solution with no loss of element to be determined. So we can use a strong mineral. Acid is a good solvent to do the with etching. So for example, we can use aqua regia for the wet etching, or even we can use HF, hydrofluoride, to decompose the salt sample. Another strong acid solution like the concentrated hydrochloric acid, concentrated hot nitric acid, or concentrated hot sulfuric acid, even prochloric acid. So all these kind of strong acid can be used for the with etching. Okay, so dry etching, the we perform the wax sample in crucible and then we heat it in the muffle furnace. Then the residue is dissolved in the suitable acid. So the typical etching temperature for dry etching is between 450 to 550. We use the magnesium nitrate is the etching acid. So and also before we put it in the muffle furnace, we have to char the sample. So charring is can be done using the open flame. K must be taken off to ensure that none of the volatile elements will be escaping during the etching. Drying etching normally we use for to remove organic substance from interfering with the analytes. So etching technique, they have advantages and disadvantages. Uh, so if you want to, as I told you earlier, if you want to analyze the sample in the solid form, we have to do the etching. Wet etching or dry etching. If you want to do the analysis in the liquid solution, we have to use a proper solvent to dissolve the solvent, to dissolve the sample. So advantage of etching is have ability to decompose a large sample size. Little or no reagent is required for the etching. The technique normally relatively safe. And then we can prepare the sample which containing a volatile combustion element such sulfur, fluorine, and chlorine. This technique we can use mass production. So, however, the etching also have disadvantages. When we do the etching, wet etching or dry etching, we will lose the analyte due to the retention to the etching container. We will lose the analyte due to volatilization. It can be have contamination of sample from the etching container or even from the muffle furnace. We can also have a physical loss of low density of ash when the muffle door is open. And then difficulty in dissolving the certain metal oxide. Formation of toxic gases also can be happen. The toxic gas in produced in the polyventilate area will be danger to the human being. So please make sure when you do the chairing it should be taken place in the fume hood. In the muffle furnace must be have the hood canopy for a proper uh, ventilation. Okay. So another etching technique, instead of wet or dry, we can also use microwave. In some cases, the dissolution of sample can be done using the microwave oven, so it can accelerate the dissolution process. So the microwave oven, the temperature is around 100 to 250 degrees C. If you want apply the microwave digestion, so the sample have to seal in the vessel, and then the sample in the vessel, the microwave digestion vessel have to mix with the appropriate acid to allow the dissolution to be taken place. So the microwave oven can be used for rapid and efficient drying and acid decomposition of sample. The advantages of microwave digestion is reduce the time to do the etching, and also it use lower blend level due to less amount of reagent required. Fusion, a weight of sample, is mixed with a flux. Flux normally is sodium peroxide in a metal or in the graphite crucible. The mixture between the sample in flux must be heated in a flame or in a furnace, that resulting the fused material leach with water or leach with any acid, normally dilute mineral acid or alkali. These techniques are required to sample type that inorganic in nature and unreactive toward acid decomposition. So, fusion considered to be the last resort for the trace analysis, because the fusion technique is a very expensive and normally not available because of due to difficult to obtain a high purity of flux. The yield of the solid solution high can salted out in the nebulizer, and then large dilution of the sample are necessary, and then we need expensive equipment to do the fusion reaction, and then spectral interference from the flux or from the crucible construction material must be considered. The contamination of the sample with the crucible construction element and impurity should be taken care, and this fusion technique use labor intensive. So some errors can be found during the decomposition in the solution of solid sample. So incomplete dissolution of the analyte, it can be cause error. So the loss of the analyte by volatilization also can cause the error as well. So introduction of analyte is the solvent contaminant. Introduction of the contaminant from the reaction of the solvent with the vessel walls. So this is all the source of error during the decomposition and dissolution of solid sample. So I proceed a little bit on the elimination of interference. Okay, what is the interference in the sample, or the interference in the during the sample analysis? Interference is a chemical species other than the analyte. So meaning that in the sample we are possible to have analyte, or we can have another chemical species. We call it interference. This interference normally will cause the systematic error in the analysis. So it can enhance or it can be alter the analytical signal of the analyte. So most of the measurement techniques are selective with a few chemical species. So it will be produce the signal that all attenuates with the analyte or not characteristic of the analyte sample. So how to reduce the interference? They have a several methods. First, masking. So we immobilize the interference to form non-reacting complex. Second way is mechanical phase separation. So phase separation to separate between the analyte and the interference can be performed by using precipitation and filtration technique, extraction, or ion exchange. Another method for elimination of interference can be using chromatography technique, or can be using electrophoresis technique. All right. So a bit detail on the method to eliminate the interference. First, by using masking. Masking agent is a reagent that chemically bind the interference in form a complex. So how to do it? We add the reagent to the solution of sample. The reagent or the masking agent will chemically bind or immobilize the interferon in form a complex. So the complex cannot be affect the signal of the analyte. So for example, during determination of copper in sample by using iodometry method. Iodometry method meaning that we applied iodine during the analysis. So the sample also may have copper ion in iron Fe3 plus. So this copper in iron will have the tendency to oxidize the iron to iodine. So as you can see from the chemical equation, it shows the oxidation reaction. But don't worry about it. So our interested analyte is only copper, but this sample they have a mixture of copper and iron. So the presence of ions 3 plus will affect the result of copper determination in the sample. So the result appeared to be higher than the actual result. So does not give the true value in the sample. So how to remove the iron 3 plus? We can adding the masking agent. So the masking agent will be reacted with the Fe3 plus and it form a complex and lift over the copper 2 plus inside the sample, and we can proceed with the sample analysis to know the composition of the analyte. All right, phase separation. So phase separation indicates at least two phases separated from one phase to another. We can remove the interference by using a phase separation. We can achieve by using precipitation or filtration. So the analyte in the interferent should have a different solubility in order to precipitate or to filter. So the sample is containing of analyte that we want to know, and also it possible to have interference inside. So in order to remove the interference by using the precipitation and filtration technique, we have to add on the precipitating agent. So depending on the solubility of the analyte in interference, one of them will be precipitated, is the insoluble species. Okay, phase separation by using distillation. So for the precipitation and filtration, the sample, the analyte in interference should have a different solubility. But for this distillation, we separate the volatile analytes from non-volatile interference. So we boil the solution of sample, and then more volatile analytes will vaporize, and then this analyte will be go along the tube and condense back to the solution or liquid form, and then we collect is the distillate. So this distillate is separated from the interference. Okay, this is the distillation apparatus. So during the distillation, we have a hot plate, and then solution of sample in the conical flask, in the round bottom flask, and then we connect it with the condenser unit. Okay, this all the condenser unit. Okay, so when the interference in the analytes in a mixture. When we heat the sample, the analyte will be vaporized, and then through the condenser tube, and then condense in the new vessel is the distillate. So this will be proceed with the analysis. Okay. All right. Another phase separation technique is by using extraction. Different in terms of solute to distribute between two immiscible liquid. The liquid is not miscible. So sample is mixed and extracted by allowing it to distribute itself between water and organic solvent. So analyte or solute is transferred from one liquid phase to another that immiscible with the first one. Okay, this is a diagram showing the extraction technique. As you can see on the top is the organic phase, and the bottom one is the aqueous phase. So this extraction technique can be done by using separator funnel. Uh, Another technique for eliminate the interference by using phase separation, it can be done by ion exchange. Ion exchange is a different instability. So you just remember different volatility, different solubility. Now we different miscibility, and then now it's a different in terms of stability. So different instability of reactant with the ion exchange resin. During the process, ion will be held on the porous of the resin. Essentially is insoluble solid are exchanged with the ions in the solution that's brought in contact with the solid. So the application normally during the water softening, water deionization. If you still remember the ionized water that we learned in topic 2 using the ion exchange technique, solution purification or ion separation. So we can eliminate ions with interfere with that interfere the analysis process. So cation exchange resin will be exchanged with the cation from the solution. So this is a resin, a solid resin. It containing of cation, normally H plus. So the cation from the solution will be exchanged with the cation resin. So we also can have anion exchange resin. Normally anion is hydroxide ion. This anion on resin will be exchanged with the anion from the solution. All right. So I think we done on the sampling. We studied, we learned about the sampling method, and then a reduction of to the laboratory size sample, and then solution of sample, and last but not least is elimination of interference. So the next video, we will continue on the evaluation of experimental data. Okay, thank you very much. See you again on the next video.